Hello everyone. So, the video of today is about a so-called coloring argument. Not racist. Anyway, so if I were to ask you, can you fill an 8x8 grid with 2x1 figures without them overlapping or anything? That is obvious, of course it works. But if I were to remove these squares, so you have an 8x8 grid and then so you remove two opposite ones. Is it possible now? Well, it isn't as easy to just see intuitively what the answer is. And the answer is actually no, and I'm going to show you why. So, with the first 8x8 grid, we had 64 squares and 32 whites and blacks. So, this is essentially what you want to do with a coloring argument, is that you have just some regular shape and then you color it to visualize, and I've already done that. So yeah, you're welcome. Anyway, so firstly we had 32 whites and 32 blacks. What? No, wait. Yeah, 32 white squares and 32 black squares. And how many white squares and black squares do we have now? Well, we just removed two black squares, so now we have 32 white squares and 30 black squares. And here you would use the coloring argument, because a black square is never adjacent to another black square, it's only adjacent to white squares. So therefore this 1x2 shape obviously always covers a white and a black square. So, and because we have an unequal amount of white squares and black squares, then we know that this is not possible, because we can fill this up, but only until we have only two whites left. Say we put down 30 of these, then we would have two whites left and 0 blacks left. And since two whites are never adjacent, we can't fill them up with this shape. So yeah, that is a so-called coloring argument. But if we change it, say that we return this square, but say I remove this square in the top left corner. So now the edge goes here. You cannot use this anymore. So we have that you can't place a square here, and you can also not place a figure over there. Is it possible now? Well, we have that the amount of white squares and black squares are equal, so the coloring argument doesn't contradict it. But we have to go further. So if you're a fan of Snake.io, you would maybe know that an 8x8 square is, well, if you don't have any obstacles or any squares that you've ruled out in this case, then you would know that there's a path you can take, which through all squares, which then returns to the first square. So this could, for example, be, now I'm including the ones I can't. We go over here, and then over here, and then we do this kind of pattern. And because it's an even times an even, then we know that we can return back. And we have went through every single possible square. So this is a pattern, and we can use this pattern to fill in our figures here. So if these two weren't excluded, then we could just place our figures along this line, meaning that we will place one over here and then one over there and so forth. So one over here and then one over there and then one over here and then one over there and one over there and then one here. That would be, so we just continue along this path. And here, since we are, so here, now, okay, if we return back to our case where we've excluded these two corners, we can use this path to prove that it still works. Because if we remove, so this path always switches between black, white, black, white, black, white. If we therefore remove a black and a white, we know that the distance between these two excluded squares, meaning the spaces that are still left between these two, are always even, because it goes white, black, white, black, white, black. So therefore, we can just think of like, we can just switch the order. Instead of we did before, we started here, we can start here instead, and then do this. And because it's always an even amount of squares in between in both directions, then we can fit these two, because this one contains two squares and it's a black square is always adjacent to a white square. So if you ever remove a black and a white square from a chessboard, you can always fill it in with one of these figures. And yeah, that was basically the end of this. So therefore, proof concluded, and that was everything I had for this video. So yeah, thank you so much for watching, and have a good one. Bye bye.